Good morning, guys. How are we doing?
Good.
Good, very good. So guys, I did upload problems from P4. We are up to P4 on BlazeView when it comes to MATLAB. A couple of you emailed me. I'm kind of repeating myself because I'm still getting these emails. A couple of you emailed me saying, how do you do, what role does MATLAB play? Well, MATLAB is a certain section, a part of your course grade. So you want to do MATLAB. The deadline is the very last day of the class, not after that. You get the whole semester to do it. I will, trickle in the sections as we move along because this is a new book for me. The homework problems from the book that I am doing in class, they're being done in class. They're parallel to MATLAB, or actually MATLAB is parallel to this. So you want to do MATLAB for practice, and you want to do some of these from your text as I do it, and you want to make sure you practice. So having said that, the main goal today is to work on the problems from P3. We have to do a little bit of lecture on P3. I don't think a whole lot. I know I did some introductory stuff last class, and let's see what kind of notes we have from P3. And if we can do some of the problems from P3, we'll be in good shape. But before we do that, I would do a few things from P4 involving FOIL, okay? And the reason I'm going to do it, because I don't know why they separated P3 and P4, okay? They're really interrelated. And if you know a little, go ahead, I'm listening.
So FOIL is for P3 and P4?
Yeah, you're going to actually see, Jack, you're going to see FOIL probably in every section. FOIL is not going to, okay? It's something they expect us to know and use it, and you're going to see it in different shapes and forms. So yes, so we're going to use FOIL, kind of build on FOIL in P4 a little bit, nothing too fancy, really. So I'm going to do it, and just knowing a few things that I'm going over will help you with P3 and P4 and everything else beyond P3 and P4. Any other questions, guys? Do you have any questions about any problems you did or anything I did last class that when you tried it, you couldn't do? All those things are okay anytime. Just like Jack unmuted himself and talked, you can do the same. Okay? All right. And if you want me to repeat something, you just have to tell me clearly. And texting doesn't work, guys. I can hardly see your text. I have so many windows open here. And in class, we look at people and I can't really look at you, and it's not your fault. Even if when you talk, you can always, I minimize the window. I can't see my face. I can't see your faces. So when we are done with lecture and you want to talk, you can always open your, what do you call it? The camera if you want, but it's totally up to you. So guys, last class, we talked about FOIL. And we're going to look at FOIL in a very specific context, okay? And let me show you what I'm talking about. This is P4, and you don't have to worry about it too much right now. here is what they're talking about. Let me bring it here. And I'll give you an example. Okay, the book does things with A, B, and which is fine, which is totally fine. But I like to do it with numbers so that you can see an example. Let's see. All right, this is P4, but again, I know I haven't done P3. Don't worry, I'll do them. Okay, so here they're basically showing us how to use FOIL in a very specific context. AX plus B, CX plus D. I'm going to take something like 2x plus 5 times 3x plus 2. Let's make it 4. I want to make sure the numbers are all different. Okay. So again, I am going to multiply the first terms, and the first terms are, I'm going to label them, underline them with this. And when I multiply them, I get 2x times 3x. 2 times 3 is 6. X times x is 6 squared. Okay. And I'm going to label the outside terms, I guess red or purple, pink, whatever you want to call it. First terms, outside terms. Okay. The red lines, 4 times 2x is 8x. And the plus sign is there because plus times plus is plus times plus is plus. All right, then I will do inside terms. The inside terms, I'm going to label them or mark them yellow. These are the inside terms. 3 times 5 is 15, and there is an x, don't forget. I know I took plus, it works the same way if they were minus 15x. And then the last one, the last terms, I'm going to make them, what color do I choose? Gray. The last terms are these 20. 4 times 5 is 20. Now, when you have like terms, and you will, you want to add them. Okay. So this is 6x squared plus 8 plus 5 is 23. And leave 20 alone. That's basically it. Okay. So there's another example of FOIL. So what they're going to do in this section P4, which we will probably work on tomorrow, they'll ask you to multiply these two terms. Okay, not a whole lot going on really, guys. So I'm going to give you 1 or 2 minutes maybe to kind of see if you have any questions.
So will we might get to P5 this week?
I hope so, Jack. I hope so. And if not, don't worry. A lot of the things, the way I see, I have an idea. I'll be very close to the syllabus, 90% easily. I sometimes don't finish it 100%. And I think we'll finish 80, 90%. Some sections are a little long. The reason I'm spending a little bit of time, maybe some of you are very prepared and it's a review for you, but I do know when we get to chapter 3, chapter 4, sometimes people will ask me these questions. That's why I'm spending a little bit of time, and it's actually not a waste. I think it's not a waste of our time. The reason because I know some of you have seen it. So the reason because later people will ask me to do these things, and today we'll do a test. We're going to do a lot of fractions today. Okay. So you're going to see. So that's kind of like a little bit from P4, but let's go back and do some of the problems from P3. Okay. Any other questions on this, guys? I'm going to get rid of this slide completely. Awesome. And of course it's there. It's being recorded, and I double checked. I'm being recorded. We are being recorded. All right. So guys, here are the problems. Okay. Once again, we're going to work a lot. We're going to work with fractions a lot in P3, and it's going to test how well you know how to add, subtract, multiply, divide. So last class we defined square root as square root of x is same as x to the power half. And this half is a power. Everything you know about exponents, adding exponents, multiplying exponents, they all hold. Okay? So in this section, we will be adding fractions, we'll be subtracting fractions, and this is how I add fractions, and I know you've done it and in 7th grade, and we're not gonna turn the class into, you know, how to teach fractions, but I'm gonna show you one. So how do you add? This is how I'm gonna subtract and add. Let's just add 1/3 plus 1/2. Okay, you do it the way your teacher taught you, but that's how most people do it in the US too. So I want a common denominator. So I'm going to multiply the top and bottom by this 2. So I'm going to get 2 times 1 is 2, 3 times 2 is 6. I want the denominator to be the same. So I'm going to multiply this 2 by 3 and this one by the same 3. Let's highlight the denominators. Okay. Basically, you take the denominator of the first fraction, multiply the numerator and the denominator by it, which will be 3/6. Okay, so what's 2/6, which is 2/6, and 3/6, which is 3/6? If the denominators are the same, you write the denominator, you add or subtract. Of course, we are adding here. If there was a minus sign, you would do minus, and your answer is 5/6. Okay, this is something I'm not going to do every time. If you ask me to do it, I'll do it on the side, not a problem, but I assume you know how to do it. That's an assumption I make. And if you do it a little differently, sure, fine with me. You don't have to worry about it. All right, so how do we multiply two fractions? We're going to mostly see addition, subtraction, multiplication, and a little bit of division too. Well, multiplication is easy as well. So how do I multiply 3/5? Let's put a line here, times 4/7. You multiply the numerators. 3 times 4 is 12. And 5 times 7, and then you multiply the denominators. That becomes your new denominator. 5 times 7 is 35. So we're going to see these things. Other than that, this is kind of like P2 with fractions. Look at P3 as a section, as a cousin of P2 with fractions. That's all. I'm going to pause here a little bit to see if people have any questions. Okay, one more thing, guys, which we discussed last class. The cube root of 27, we write it like this, or we can also write it like this, is like asking what number multiplied by itself 3 times. I don't like the idea of writing x. Let's call this number n. N times n times n is 27. What's n? It's really like asking that question. The answer is 3. You have to kind of think. Of course, you can use your calculator. 3 times what times what times what? You would say, well, it has to be 3. So the cube root is 3, and the cube root doesn't have a negative sign because -3 times -3 times -3 is not positive 27. It's negative 27. One more thing that we discussed last class. Square root of 25 can be written as follows. And you want to see both. And you're going to see both. And you have to do that translation in your head. And of course, this is plus minus 5. Why? Because let's get rid of this. This is not helping me. Why? Because, excuse me, 5 times 5 is 25, and also -5 times -5 is also positive 25. So when this fraction is even, it works with 4, 6 for the same reason. When this fraction has an even denominator, you stick a plus minus. When this fraction has an odd denominator, you just stick to, it could be -2. If I put -27, if I gave you cube root of -27, you would write -3. Okay, so it'll be either plus or minus, but not both. Any questions on how we define cube root? This is read cube root of 27. This is called square root of 27. And this will gel when we do some problems. All right, guys, seems like we are ready to roll. Again, I gave you a lot of problems, right? But it's not a big deal. You need to practice. Okay. When they say rationalize the denominator, it has a very specific meaning. These I'm not going to worry about. Let me see which ones I assigned 1 to. I'm not going to worry about it. I can verbally do it. Square root of 36 is 6, plus minus 6. Square root of 25 is 5, plus minus 5. No big deal. Let me say, okay, let me look at this one. 45, let's try some of these. Again, you're going to see we are going to use, what do you call it? I'm going to do 1 or 2. We're going to use FOIL. Excuse me. Okay, so guys, look at the language. That's the language I'm going to use on the exam. So make sure you read it. I try to leave it here. It says rationalize the denominator. That's what we're doing. We're not solving for anything. We are rationalizing the denominator, and I'm going to tell you what it really means. Okay. So mathematicians, for some reason, don't like radical sign in the denominator. Okay, they want to have it. By the way, rational number is like 3, 2/3, 3/4. Radical signs are irrational. Okay, anything with a radical sign of 5, 3, they're called irrational. They don't like irrational number. They want the denominators not to have any radical signs, informally speaking. Okay, and I'll give you some of these on the exam. Okay, so you're going to write the whole thing so that there is no radical sign in the bottom. Okay, so something magical happens, guys. There is a fancy word called conjugate. Conjugate, okay, a little bit of fancy word for you guys. What's a conjugate, guys? The conjugate of this is simply, conjugate kind of means partner, spouse, something like that. Okay, the conjugate of square root of 5 plus square root of 3 is square root of 5 minus square root of 3. Okay, the conjugate of this is this. Okay, the conjugate of this is this. So if you're my brother, I'm your brother. It's kind of like that. It's this relationship has a specific name. So let me give you another conjugate. So the conjugate of this doesn't have to have all radical. The conjugate of this is this. Okay, another one. Let's do this one in red. The conjugate of this is, and why do we care? Well, we're going to find out. Awesome. So do we kind of want to, we're going to use that word conjugate. I'm going to say, well, multiply the numerator and denominator by the conjugate of the denominator. I'm going to say that's what we're going to do. And when we multiply, we're going to use FOIL. No big deal. So do we understand, guys, what we mean by conjugate?
Yes, the inverse.
Exactly. Well, save the word inverse for inverse. Inverse has a very specific meaning. In math, for instance, the inverse of 2 is half, but I know why you're saying it, okay? So let's just say conjugate. It's kind of like the opposite partner, something like that. I understand your point. Your point is well taken. So let's work on this problem. And we're going to use FOIL to see that this technique works. Okay? So if you multiply, our goal, when we say rationalize the denominator, that's a fancy way of saying get rid of the radical signs from the bottom. And how do we do it? Here's how. If you multiply the top and the bottom by the conjugate of the bottom, I'm going to be very careful. Very easy to mess up because the conjugate of what I wrote in red is the black denominator and the conjugate of the black denominator is the red denominator. Don't mess it up. So this is the original fraction, the original expression with radical signs. And this is the conjugate of that expression. Now, if I do FOIL with the bottom, trust me, the radical sign will be history. Okay, so let's see what I can do here. There are a few things I really like about doing things on the computer. Okay, so what I'm going to do, guys, I'm going to use a different color, and I'm not too concerned about the top. Top is very easy. You're going to distribute 6 over, there's nothing going on. So with the bottom, guys, let me use a different color. Let me use green. So remember, guys, from FOIL, and we did a little bit of FOIL, first terms, what's square root of 5 times square root of 5? Square root of 5 times square root of 5. Remember, guys, this is really 5 to the half. And this is also 5 to the half. And the base is 5. When you add half to half, you get 1. The answer is 5. So when you multiply, I'm going to do it here. Okay. The first term, square root of 5 times square root of 5 is 5. So I'm going to write 5 here. Okay. Then the outside terms. Okay. The outside terms are radical sign 5 times -3. I'm going to write it here. There's not a whole lot you can do. Okay. You have to leave it here. These are the outside terms. And what are the inside terms? Positive square root of 3 times positive 5. Well, which is, I'm going to leave it here. And finally, the last terms, square root of 3 and negative square root of 3. Okay. Now I'm going to show it to you here, just like before. Square root of 3 times square root of 3 is 3. And this plus and this minus will make it minus. So I'm going to write -3. And just to be consistent, let's stick this 5 here. Now this guy and this guy, they're really the same, except for they have opposite signs. They cancel each other out. What am I left with? 5 minus 3. Look, the radical sign is nicely gone. We have eliminated it. And what happens on top? I have 6 square root of 5 minus 6 times square root of 3, and done. And you're going to write 6 times square root of, let me see what I can do, guys. Oops. Sorry. So I'm going to say 6 times, there's nothing going on top. I can't do anything. And I'm okay with radical signs being on top. 5 minus 3 is 2. This is my answer. Now, most people, well, let me just, if you will ask me to do it again, I will, but I do need this much room. So most people expect you to, this 6 and this 2, they cancel, and you're going to get 3 square root of 5. And this 6 and this 2, they also cancel, and you're going to get 3 square root of 3. So most people expect you to do this. So this black expression as a part of number 53 boils down to this. And just to let you know, these are some of the things you can't really do it on your calculator. So you pretty much have to know how to do it by hand. I'm going to pause here a little bit for you to process and ask questions, okay? Let's do one more, guys, okay? If you have any questions, if you do, unmute yourself and just interrupt anytime. I'm gonna get rid of this guy. Let's do one more. So I'm gonna say it, but I'm not gonna write the conjugate separately. That's what I'm doing. I'm gonna find the conjugate of the denominator, which is square root of 7 minus, no, plus square root of 3. And I'm going to multiply both the top and the bottom by the conjugate. And I'm going to just FOIL it. Okay, now I'm going to FOIL it, but most of you will figure out it's going to be 7 minus 3. Okay, most of you will eventually figure it out. Okay, square root of 7 times square root of 7 is 7. I'm going to do it here in a different color. Okay, this is just the first terms. Same argument, 7 to the half, 7 to the half, you add it up, you get 7. Okay, what about the outside term, square root of 7 times square root of 3? I'm going to do it here. Square root of 7 times square root of 3, nothing going on, leave it alone. What's the inside term? Negative square root of 3 and negative 7. Well, not a whole lot going on either. And what's the last terms? Negative square root of 3, negative square root of 3, it turns out to be negative 3. So I'm not going to worry about this. They will cancel. They're the same thing with opposite signs. So I'm going to go here and just write 7, this 7, and this negative 3 right here. And you can do your work. Sorry, you can do your work on the side. You don't have to show all the steps, even if we were to take a face-to-face exam. Well, I have to worry about the top. There's not a whole lot you can really do. You can do it like this. And then I'm gonna see what I can do a little bit. I'm gonna leave this guy alone. There's nothing going on. I'm done. 7 minus 3 is 4. I don't have to divide 11 by 4 because 11 is not divisible by 4. So that's called rationalizing the denominator. And we have done 2 of the hard problems. You're going to see problems like this on the exam. So I'm going to pause here a little bit to see if you have any questions. Any questions, guys? People are very quiet today. We have 19 people. Are we doing okay, guys?
Yeah, everything's okay.
Awesome, Jack, and hopefully everybody else is okay too. All right, guys, moving on. Don't be shy. Feel free to say, hey, could you do one more? Could you explain this again? By the way, this whole rationalization of the denominator will come up again, even in this section. We're going to see it right now. So you're going to see that they expect you to have no radical signs in the bottom. That's understood. I'm going to do one problem before this kicks me out, but if it does, you know the rule. I'm going to come back. So let's do some of these. So this is not a big deal, guys. All they're saying, you're going to apply the same thing, same exponent rules, except for this time they will be fractions. Let's do 92, and then I'm going to do 98 and 100. Okay, that's my plan. Okay, let's take 92 and carefully do it without messing it up. Fractions are very easy to mess up. So I'm really talking to myself. I try to stay extra alert. All right. Okay. A little bit of review. Remember, guys, I don't have to write it like this, but I'm going to. You multiply the like terms. You could have written 12. And what's going on here is 2/3 times, no plus, 3/4. Okay, if the bases are the same here, they are x. I add the powers or exponents. So I'm going to write 12 here. I'm going to write x here. What's the power? I'm going to show you right now, but I know you guys can do it. If I multiply the top and bottom by 4 of the first fraction, I get 8/12. If I multiply the top and bottom of the second fraction by 3, I get 9/12. And 8 plus 9 is 17/12. So that's my answer, 17/12. Done. You didn't even need the second step that I wrote. You could have written 12 times 17/12. Yes, to do 17/12, you have to kind of do a little bit of math on the side, which is here in the bottom. Anybody is trying to talk? Don't be shy.
It's very self-explanatory.
Good, good. So you're following. I hope your friends are
Yeah.
following too. Good. Okay, awesome. So thank you for the feedback. So guys, let's try number 98. Okay, number 98. Remember, guys, when you have a power over a power outside parentheses, however you want to say it. However you want to say it, doesn't matter. And take this guy here. Okay, so I am gonna do a few additional steps. I'm gonna find the cube root of 125. By the way, to the power 1/3 is another way of saying cube root. I'm gonna write it like this. People don't, for some reason, they like powers. They're easier to see instead of the radical sign. And here, I'm gonna do it like this. I'm showing an additional step that most of you probably will skip when you're doing things on your own. All right. So what's the cube root of 125? Well, what number multiplied by itself 3 times gives you 125? The answer is 5. 5 times 5 times 5. You can check in your calculator. So this is that. And there's no plus minus, just plus. All right, this sign, the one you put whenever this is odd, will be either plus or minus depending on what's here. What's x to the power n times 1/3? Well, x to the power 9 times 1/3. 9 times 1/3, we multiply. When you have 2 powers, you multiply. And 9 times 1/3 is 3. So you write x to the power 3. And you do the same here. You write y to the power something, and 6, you multiply the power 6 and 1/3. And 6 and, say that once again.
Would that be 2?
Absolutely, and thank you. So that is done. We're done. This is scratch work. This is the main work. Do you want to skip step 2? Be my guest. And the reason I'm doing a few additional steps is because when we do chapter 2, chapter 1, they kind of expect you to do these things in your head. That won't be the focus. So might as well do it now. So that next time I'm say, remember we did that in P3. I'll give you a couple of minutes to kind of, I think it's not a bad time, guys, to switch. I will continue our work. Let's get out of this session and come back really fast. I'll see you soon, guys. I'm jumping out of this. It's going to kick us out anytime.